everyone. In today's video, I'm going to solve this calorimetry problem. So we will see a lot of things in here. Let's go directly read the problem and talk about it. So a 50 kilogram block of ice at negative 10 degrees Celsius is dropped into calorimeter, where the calorimeter is negligible heat capacity uh, containing water at 25 degrees Celsius. When the equilibrium is reached, the final temperature is now 10 degrees Celsius. So this is the final temperature. Um, how much water did the calorimeter contain initially? All right, so we are looking for the amount of water that was there initially. Okay, that was there initially. All right, great. So some specific heat capacity of ice is given here. All right, and then for the water is also given here. And there is another given, the latent heat of fusion of water. So the first step is we have to understand the overall idea of this, and then we have to sort out the givens, and then we have to know some of them, or some process is gaining heat and then some other process is losing heat. So I would do like this. I would start like from the concept. So this is the ice, I would say. All right, this is the ice. All right, this one is the ice. So in this ice, I have mass of the ice, right? Mass of the ice, which is equal to 50 grams, okay? 50 grams. And then temperature of the ice is given as negative 10, right? Negative 10 degrees Celsius, that's given. And then the specific heat of the ice is 2090, right? 2090 joule per kilogram degree Celsius. This is also given. Well, this must be added with a water, right? In a calorimeter. This is the calorimeter or a container that has negligible heat capacity. So we don't know that is mass of the water here, okay? That is the question mark, because they are asked what is the mass of the water there originally. So the mass of the temperature, I'm sorry, the temperature of the water, area this one, the temperature of the water was initially, temperature of the water was initially 25. Okay, this is 25 degrees Celsius. That's good. Okay, and then we know the specific heat of water is given as 4186. Okay, this is of course joule kilogram degree Celsius or degree Kelvin, because change of degree Kelvin is the same as degree Celsius. So when we add these two of them, well, the heat must be zero, right? Everything after this whole process, the sum of the two heat gain plus heat lost is equal to zero. Or in other words, um, heat gain, right? This is heat gain. Q is heat gain is equal to minus Q lost. Okay, all right, this is just heat gain, heat loss, or just a negative. Be careful. So this is the positive and then this is negative, so when we add them together we must have a zero. All right, now what we have to do next is we have to recognize what's going on, how many processes we have in the first scenario. So there are three things. The first one is mass of the ice, right, and specific heat capacity of the ice, and then that delta T. Delta T in here is what? To move the negative 10 degrees Celsius into zero. This negative 10 must come to zero. Okay, so that means the zero minus of minus 10. Okay, this is the first one. This is the first one. So this is degrees Celsius. And then plus, what happened next? After this ice completely reached a 0 degree Celsius temperature, the whole ice, which is the 50-gram ice, must be melted completely, melted completely. We have to use there now the mass of that ice, right? And then the latent heat, okay? The latent heat of fusion of water, I mean ice, which is it is given already latent heat of ice is 33, we forget this, it's on the top, times 10 to the power of 4, right? 10 to the power of 4 joules. Okay, so we need this amount of heat per kilogram, okay, per kilogram, to melt everything in the ice. Okay, and then the third one is going to be plus, again, now everything is melted, everything is at 0 degrees Celsius. That 0 degrees Celsius again must go to the equilibrium temperature, which is the equilibrium temperature was given as 10. Okay, temperature common, we can call it temperature common, is just 10 degree Celsius. Okay, look now, initially the water, the unknown mass water was 25, it will lose heat and then it will become 10, and then the ice was negative 10 and then it will become to 10, because after all those three processes, and then it will reach to 10. So 10 is going to be the common temperature. All right, now, so the third process is this one, mass of the ice still, but this ice is now changed into water, but I don't want to confuse with the other mass, so I say just mass of the ice, but technically this is water because it's melted already. So that means I have to use the specific capacity of water in this case. Okay, and then times delta T. Delta T is what now? Delta T is the common temperature, right? The common temperature, which is the final temperature that's going to be reached, the 10 degrees Celsius minus 0. All right, because the 0 is the initial and this one is the final. Okay, so the final is the 10, the 10 is just the common temperature. So this is the left side of the equation. Okay, remember, these are the three different processes that we have to recognize. If we don't know these three processes, it's not going to be work. So this is the first process, this is the second one, and this is the third one. Three different processes in the left side gaining the heat. All right, the heat loss is going to be like this. Okay, the heat loss is the negative, all right, the negative of, okay, mass of the unknown water, it was originally in the calorimeter. Okay, times what? Specific heat capacity of water, C of water, times change of temperature. Now what is the change of temperature here? Now the change of temperature is going to be what? Well, the 10, which is the 10 degrees Celsius, which is the final, minus the initial change is delta temperature, minus temperature final minus temperature initial always. So the final temperature is this, the common temperature, which is the 10 degrees Celsius, minus minus what? The initial was 25, right? The 25 degrees Celsius. Here we go. All right. Now, at this step, you have to recognize that. So this is negative outside, this is negative outside, all right? And then this is 10 minus negative 25 is negative 15. So it will give me negative number inside the parenthesis. So negative times negative is positive. Now recognize that everything is just positive. I'm gonna take only the number in the next step. Okay. So let me plug in the numbers now. So mass of the ice is 50 grams, which is 0.05 kilograms in other words, right? And then the specific capacity of the ice is 2090 joule per kilogram degree Celsius or degree Kelvin, because change of degree Celsius is change of degree Kelvin is the same, all right, when it comes to change. And then that's going to be 0 minus minus 10 is plus 10. Okay, 0, this one, 0 minus 10 minus 10 is 10. That's going to be 10. Okay, this is 1 plus. Okay, let's go to this one. Mass of the ice is the same thing, 0.05 kilograms. Okay, times latent heat of fusion. Okay, that's 33. All right, 0.5 times 10 to the power of 4 joules. Okay, just close it. All right, and then the third process plus, I'm here in the third process. Okay, mass of the ice, which is now turned into water, 0.05 kilograms times specific of water, specific capacity of water, 41.86 joules per kilogram degree Celsius. Okay, this is it. So equals to the negative of the right side. Okay, the negative of positive right side. Now I have a positive number in the right side. Let's squeeze the left side first, and then I'm gonna come to the right side. Okay, so let me squeeze this one. Okay, if I multiply this, okay, if you multiply the left side carefully using your calculator, that means if you multiply this right here, it will give you 1045. This is 1045 joules, because the degree Celsius will cancel the degree Celsius here, the kilogram will cancel with the kilogram here, and then that's joule. Plus the second one is going to be 16. Use your calculator and check it. 750 joules. Okay, still the kilogram will cancel with this was joule per kilogram. Okay, for it, then the kilogram will cancel, and then joules. Plus the last one is 2093. This is 2093. You can check using a calculator. This is joules, because everything is now in joules. So the temperature, everything. Okay, we forget the temperature here. What is the temperature here? The temperature is 10 minus 0. Okay, we forget the temperature is 10 minus 0. Okay, give me that. So specific heat capacity times the temperature. That temperature is 10 minus 0. Okay, this is 10 minus 0 equals to the right side now, because this is 10 minus 0 right here. That 10 minus 0 is this one. Okay, this right here. So this will give me 2093. Okay, and that is degree Celsius. That degree Celsius will cancel with degree Celsius, and then I have joule finally. Now equals to, all right, equals to. Now go to the right side. The right side, as I told you earlier, this right side is now a positive number, okay, because this is negative and then not negative. 10 minus 25 is negative, and then this is negative, that's positive. So mass of the unknown water, okay, mass of the unknown water times specific capacity of water is already given, that 1418.6 joule per kilogram degree Celsius, right? And then this is 15. Okay, this is 15, positive 15, because negative times negative is positive. Okay, all right, good. So if I add all these three left side, it's gonna give me 1988 joules. Okay, and then the right side will give me 6. If you multiply this 4186 times 15, that's gonna give me 62790 times mass of the water. Okay, so degree Celsius will cancel with degree Celsius, right? All right, per kilogram, and then the kilogram will be the unit of this one when I just divide it. So mass of the water is equal to 19, divide both sides by 60 to 70. Okay, 19888 joules over, okay, this one, the right side, which is 62,790 joules per kilogram. Okay, so when you calculate this one, you simply get 0.3167 kilograms, and this is approximately, if you multiply by 1000 kilo minus 1000, if you multiply that, this is going to be 316.7 grams. Okay, 316.7 grams. So this was the initial amount of water that was in the calorimeter from the beginning. All right, I hope you enjoyed the video. I will see you another time.